Okay, guys, I'm going to go ahead and stop you because it sounds like most of you did this yesterday. Hopefully that was the case and you've already done that knowledge probe and prediction for today's lab. If not, that's what you're supposed to be doing for the past 6 minutes. You also need to make your way to that website. It's actually one of the first things in your procedure steps. But before we get to today's lab, I want to make sure to go over a couple of things so that everybody's clear on what you're doing. So first of all, I know everybody's in a group because I just walked around the room. But there should be 7 groups total in here of 3 or 4 people. And so let's talk real quick about that knowledge probe because you had a few questions on there. But whenever we examine this lab today, if you haven't looked at the procedure, you'll be obviously reading that in a moment. But you're going to be looking at an interaction between 2 carts, a collision, some type of collision. We have 3 different types that are going to be tested. But for a collision of 2 carts, what are possible ways that we can define our system? We talked about defining systems yesterday. What could we focus on when we look at a collision between 2 carts? Sorry? Okay, I don't mean just the type isolated. I mean like what would our system be? What object or objects could we include? The carts. Okay, so 2 carts. We could have a 2-cart system.
Or 2 carts in the room.
Sorry?
2 carts in the room.
Yeah, so if you wanted to include the track, that's going to make your job a lot harder if you're trying to do that. But yes. Just one of the carts, right? So you could let's say we have cart A and cart B. They're defined by color in the lab, but let's just call them A and B for right now. You could have the system that's cart A, just cart A. You could have a system that's just cart B, or you could have the cart A, cart B system. Okay, so those are different ways you could define the system and then start to analyze that collision. If you start to include the track in there, you've got more variables to account for, so I would not recommend trying to do that. But you would specify the objects in those systems. I don't want the vocabulary terms from yesterday, so don't just write isolated. Don't do that. Okay. Tell me what objects would be in the system. Okay, for that particular question. Okay, and then the lab question itself asks us if momentum is conserved. After collecting our data, how will we know if the momentum is conserved? What are we going to see in our data if we have conservation of momentum? It's going to be the same. Yeah, so the initial momentum is going to be the same as the final momentum. That's how we know that it is conserved. So if you see that, okay, then you can make that conclusion accordingly or according to your data. Okay, so again, just a couple of things to keep in mind. So each group today is going to be performing a different type of collision. Your investigation plan begins on the lab paper. However, there are steps that are unique to your collision on a half sheet of paper, and these half sheets of paper are already at the lab stations around the room. The one I have right now says stick together different masses because that's one of the different types of collisions. And this is where your lab steps continue. Okay, because they stop at number 10 on your paper, and then you'll read the little half sheet at your lab station to perform the particular type of collision you have. Some of them, I told you there's 3 types. You'll see them all tomorrow because if you haven't looked ahead, you guys have to present your lab findings tomorrow because you're only testing one type of collision, and so you need to get the information from the other groups so that you can also analyze the other 2 types of collisions. Okay, magnets are going to be provided at different lab stations. So the carts have a little insert that has a magnet in it, and they may or may not already be in the cart. So you'll see it whenever you get over there. But if you are trying to do a stick together collision, your magnets need to be turned so that they are attractive, so that they actually will stick together. If you're doing the bounce collision, the opposite's true. You'll want them to be repulsive so that they will push apart. And if it's recoil, you don't need any magnets at all. If you have a question about that when you get there, you can let me know, but they should be at your lab stations. So for the rest of the period today, you're going to be gathering all of your data. You are doing 3 trials, so make sure that you get everything that you need done today because we don't have additional class time allocated for this. And then you need to complete the questions, or at least 1 through 6, of the data analysis prior to class tomorrow, because when you come into class tomorrow, you're going to be, again, doing a presentation. So the first thing you're going to do is start putting your findings on a poster, which means you need to understand what your findings mean. So your homework or classwork, if you happen to finish with enough time to start on it today as a group, is to answer those questions in the data analysis so that you can be ready to present your findings tomorrow. Again, you will not have additional class time to run further tests, so if you're not finished at the end of the period, you need to plan to come in after school. Okay, so I'm going to go ahead and let you guys get to it so you can get this taken care of. Everybody has a group. There are lab setups. There's 2 on each of the counters, except this one over here, there's just 1. So please go find one, and then if you have questions, let me know, but please read your procedures.